Okay, we're live. If if I'm right, I did not see anywhere to post our video from our review, so hopefully that's not something that needs to be posted.
I didn't see any place either, so I think we're good.
I hope. I'll make sure this one gets posted, but I didn't see anything for that one, so.
Okay. All right. So,
So this one was a little bit different, kind of a little bit more in-depth, I guess.
yeah. It kind of goes back to what we learned those first 2 days or 3 days, I guess.
Yeah.
So, with this, the null hypothesis is status quo.
Yeah, so
And then alternative hypothesis is what we go to if that's not true.
yeah, your null is HO and your alternative is HA, right?
Right, right.
Okay. And then, did you get the different type of errors? Did you understand that part?
The different type of errors.
Mm-hmm.
I don't even remember errors. I feel bad. Oh, type 1 and type 2.
Yeah, what was it?
Those ones?
The type 1 error is committed when we reject a null hypothesis that is in reality true. A type 2 error is committed when we fail to reject a null hypothesis that is in reality not true. So if you reject a true hypothesis, it's a type 1, and if you accept a false hypothesis, it's a type 2. Is that what you got?
Mm-hmm. Yeah. So you reject it, but it's true. 1. You accept it, but it's not true. 2, right?
Which one?
So if we reject it and it's not true, that's type 1. Am I getting those two mixed up?
Type 1 is if we
Oh, sorry, not true. By not true, I meant it is true.
Yeah, type 1 is if we reject something that's true, and type 2 is if we fail to reject a hypothesis that is not true.
Okay. Okay.
So did you get part 1 done?
Not all of it.
Okay.
We don't. I don't know. It's up to you. We don't have to go over that because I can just go back over it.
Do you want to start with part 2 then?
Yeah, sure.
Okay. Okay. The graduate management admissions test is used as an admission criteria in many Masters of Business Administration programs. The score on the GMAT in the past has a mean score of 529. The BYU professor feels now that the score has improved within the last couple years. Determine the null and alternative hypothesis. So your null hypothesis would be that the scores stayed the same, right?
I think so. And then your alternative would be the hypothesis of the professor that feels like they've improved.
Yes.
Okay.
Okay. Suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still 529. Was a type 1 or type 2 error committed?
That would be a type 1 because we rejected it, but it was correct.
Yes, I'd agree.
Okay.
If the analysis was done at a 0.01 level, what is the probability of committing a type 1 error? That's 1%, right?
I think so. Yes.
Okay.
Now, I just want to make sure that I'm getting this right. In this case, what does alpha is equal to... Sorry, alpha is the probability.
I believe so.
Let me... Oh, okay. I don't remember exactly, but I do remember him saying that something about this in one of his first videos. Was if alpha was equal to 0, we reject the null hypothesis. We fail to reject the null hypothesis. I don't remember.
Same.
It's the level of significance. If p-value is less than alpha.
See, it says that alpha value is the probability. So yes, alpha is a probability.
Okay. And it stands for the level of significance.
Well, if the alpha value, which is the probability of committing a type 1 error,
Uh-huh.
and then if that's small, conversely, the probability of committing a type 2 error will be large.
Okay.
So yeah, alpha is going to be your probability of making a type 1 error. So
Okay.
so that's
then,
a 1% chance.
So then with this next one, if we want to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance? The level of significance is alpha, and so we would need to increase alpha in order for for there to be less of a chance of getting type 2.
Right.
Okay.
Okay. Second question.
Okay. Study by the National Association of Retailers reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of person buying a second home as an investment rental property was 47 years. Assuming the national standard deviation was 5, a real estate agent wants to determine if the average age of those buying investment property in his area is different than the national average. He randomly selects 15 of his clients who purchased an investment property and obtains the data shown.
Okay.
Let's see. There's our data. First, design the study.
Well, the population would be from his customers of second home buyers. What would be, right?
I think, or would it be the national, the national population of those people buying second homes. I don't know.
I'm thinking it's from his because he knows
Because
the national average. He wants to see if his varies. So
okay, because it says that if the average age of those buying investment property in his area is different than the national average, so you're right.
okay, and then he just
Or would it just be those buying second homes in his area?
yeah, it could be those from buying second homes in the area. Then we just have random sampling for his sample. Um,
If he's sorry, if the population is everybody in his area though, would it be simple random sampling because he's taking 15 of his clients?
hmm,
Or would it be thinking either not cluster, systematic, not stratified or convenience?
hmm, I'm not sure. Well, because I know in B it says the ways that he could randomly select his sample, so I think that we would decide whether he just randomly picks or he randomly picks by.
Right. I think that if it was of all the people in the area, it would just be a simple random sample. But because it's
Mhm.
just his clients, I think that it is convenience, and then from his convenience, he did a simple random sample.
Okay, yeah, I'd go with that.
And then the research question is if the average age is the same, or if it's different, I guess.
Okay. So then B, I think we kind of already answered. He can just use a simple random sample. From,
Mm-hmm.
okay. Okay. Mhm. Mhm. Okay. And if you look on the answer key, it looks like the next couple of parts they use the SP. Um,
SPSS.
yeah, it looks like they use that on those. So I don't know if you want to be able to go over there, but it wants to find his mean, his standard deviation, variance, minimum, Q1, median, Q3, maximum.
I don't know. It's up to you, Bernie. I'm kind of fine with not doing that because I think
I'm
I know how to
fine.
do it. But if you want to, we can.
I'm good unless, we can go over there if we have to for the quiz, but
Okay. I'm just gonna open it up just in case. Anyways. Oh man, sorry, I have a bunch of gunk in my throat.
so basically his mean is 46.73333333. So we'd have to get the z-score.
Okay, now which one are you on? Which question?
Oh, I guess D1. Do you see that one? I guess we need to do those ones first.
Okay.
Since there are only 15 pieces of data, what will you need to check?
Well, I feel like I'm cheating because I just looked at the answer key. But let me see if I can explain why. Make a QQ plot to check for normality.
Well, I think isn't the QQ plots like the ones we looked at where if it was kind of a gradual diagonal line, it was normal, and if it kind of swooped up or did different things, it was not normal?
I think so. Yeah.
I'd agree with the answer there. You know, make a plot to see if it is normal.
Okay.
So state the null and alternative hypothesis. So null is going to be that your average age will be 47, and your mean is that your alternative is that the average age is not 47, right?
Yes. So I just had to check the thing again. I didn't. But yeah, you're right. So null is if they are equal to 47, and the alternative is if they're not equal.
Right. Okay. So are you ready to compute our z-score?
Yeah. Compute the test statistics. Is that just a fancy way to say find the z-score?
Yeah, I think so.
Okay, here's my question. So our z-score is equal to our measured value subtracted by our mean over our standard deviation.
Yes.
What's our measured value?
See, in this one, I think you're going to go with the mean, right?
Well,
you go with the 46.733.
Okay, yeah.
And then you subtract 47 from that. Okay. And level of significance, is that just going to be or are we doing, because the only standard deviation we have is for this particular study. We don't have the other standard deviation.
But we can find the standard deviation because we can just do standard deviation over the square root of n. So do our observed value subtracted by our mean over the standard deviation divided by the square root of n.
Okay.
Because our n, we know, is 15.
Right. So do we do our standard deviation as the 8.827?
Sorry, just give me a second to write that. So 5 divided by... Good question.
Well, let me do it and see if I come up with the answer they got.
I came up with something really close. But that was doing it with the national standard deviation.
Hmm.
Let me try one.
Yeah, I'm not close. I got negative 11 point or 0.118. Let me look over test statistics again real quick. Okay. Are you seeing anything on it?
Not yet.
Because I'm not seeing where to find this, the how to figure the standard deviation. Are you?
Not so far. It says that their x-bar is the standard deviation over the square root of n. No, never mind. I read that wrong.
Hmm. Let me try one thing. No, that's too far out there. Okay, well, I can't figure out where they're getting their standard deviation from.
So far, me neither.
It says standard deviation has to be known. Oh my gosh. It was in the question. If you go back, assuming the national standard deviation was 5.
So we
You
just,
go back and look in the big paragraph under number
right.
2.
So X is going to be 46.733.
Mm-hmm.
Our mean is 47. And the standard deviation of 5.
Yeah.
That doesn't give me the same answer, though. That gives me negative 0.0534.
Okay.
That's where I'm a little bit confused.
Well, I got negative 0.207, so kind of close.
Oh, yeah, you were right. I used the wrong formula.
Well, because that's where we get our mean, right? And our means are...
Let's see. Our mean had repeating 3s, right? Okay. Let me try this one more time. I'm just going to put in a bunch of 3s after the 7. See if that changes it. That gives me negative 206 or 07.
Yeah.
I
Let
know
me see
that.
if I can figure this mean out real quick.
Okay. I'm gonna see if I can find anything from the reading to help us, because I feel like the level of significance might have something to do with it, but I don't remember how it affects it.
Okay, if I do the mean on my calculator, it's 44.6. Let me try that. 44.6. Still going to give us a negative number, though. And that's negative 1.859. That's not anywhere close to what we need.
I don't know.
Yeah. No, I just redid it. It is 46.733333333. Um,
What are we doing that's wrong? Our mean is 47. Sorry, was it 47.33333 or 46?
46.7333333.
They might have a video on the iLearn about it. Yeah, they do.
Hmm.
11 minutes long. What?
Let me take a look at something real quick, see if.
Okay.
How did he sample the question? We're going to show you how to do that. For deep. Now remember, there are less than 30, and we don't know if it comes from a normally distributed So, I'll show you. We're on Excel. And then remember also, so the non-hypothesis is wondering about both and not care. Our population know that our is 5
He's using the same data that we are.
They're using the same data we are?
Yeah.
So where are we messing up?
This is what we did. So they used 46.73. We
They
used
used what?
we used more decimal places than they did. If instead of doing 46.733, you do 46.73, you get negative 0.209.
Hmm.
So we were right. We were
We just took a little bit farther than they did, somehow.
huh?
We just took a little bit farther than they did, I guess.
Yep.
Okay. So then the p-value, we just put it in the little
The-
tester there, right?
P-value is 0.8344.
Mm-hmm.
Okay.
So level of significance was 0.05, and the p-value is 0.8344, so we fail to reject, right?
Yes, because if what's the little rhyme thing? Um, if the p-value is less, no, that's not the rhyme. But yeah.
Okay.
There was a little rhyme in the reading there. I'm not going crazy, am I?
Okay, so then the last couple is basically state your conclusions. Well, we can't say that there's a difference between his area and the national average, right? So we have to accept the null hypothesis.
Mm-hmm.
Okay.
Because we rejected the null, and they're basically the same.
Okay. You take the quiz?
Yep, I think so.
Okay.
I guess we'll find out.
1 and 2 look pretty easy.
That's always nice.
So- Okay. Are you ready for 3?
Yes.
A hypothesis test consists of 2 hypotheses, the null hypothesis and the alternative hypothesis. Which one represents the status quo?
That would be the null.
Okay. That's what I would say too.
Okay. And then number 4, which hypothesis involves equality? That would
The
also
null.
be right?
Okay. Yes.
Okay. Sorry, we both said something at the same time.
Oh. The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer question 5. When computing the probability, which hypothesis do you assume to be true? Isn't that null as well?
Mm-hmm. So then,
Which of the following represents the alternative hypothesis for a two-tailed test?
it would be that the mean is not equal to 10.
That's what I would say. Do you remember these left tails and right tails in the reading? I don't remember that. I might have skimmed over it, but I don't remember that.
So this is just the first. I just searched
Oh, okay.
tailed, and if it's one-tailed, then it says that our alternative hypothesis will be mu is less than the observed mean. So in this case, if it was left, then it would be less than 10, but if it was right, it would be greater than 10.
Okay.
But where it's two-tailed, it's not equal.
Right. And so then
Oh.
that answers 7 and 8 too, right?
Yeah.
Okay. Nine, which relationship would result in failing to reject the null hypothesis? That would be a p-value of greater than a, right?
Yes. And then the next one, when would we reject the null hypothesis? That would be if the p-value is less than alpha.
Right.
Okay.
So an insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information for questions 11 and 12. Which of the following would be the appropriate alternative hypothesis? The average claim amount is greater than 1,500, right?
I think so. And then the next one, with the null hypothesis, that would be that the average claim is equal to 1,500.
Mm-hmm.
Okay. So in 13 through 15, the insurance company randomly selects 40 claims and calculates a sample mean of 1,650. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
I would say yes.
Yes. I
And
agree.
then-
Because of the central limit theorem?
Yes.
Okay.
Which of the following is the test statistic?
I think it's Z. Because if you remember that one question that just took us forever, we were just calculating the Z-score, but the question asked for the test statistic.
Yes, so Z.
Okay. Okay. So then the historical mean of sales received at a grocery store, 150 with a standard deviation of $40. Man, that's an expensive grocery store. Or maybe it's just in a heavily populated LDS area where everybody has 10 kids.
Okay, so our formula for this one's going to be 144 minus 150 divided by 40 divided by the square root of 36, right?
Yes.
I think the pizza man has
Can you hold on just a second? Sorry.
Not a problem.
Good. Teddy. There you go.
Teddy bear. Teddy bear, no cartoon.
Thank you.
Bye.
Okay, sorry about that.
You're good.
Okay. Uh,
Okay, so the z-score that I got was just negative 0.9.
that's what I got too. So I just
Okay.
put negative 0.900.
Idea. Okay, so what's the p-value associated with the z-score? I'm guessing that this one is just going to use the left area. It's going to be left-tailed because our alternative hypothesis is less than 150.
Right.
Okay. Okay, and then the next one, do we reject it? Let's see, our p-value is greater than our alpha, so we fail to reject.
Yeah, just a second. Let me get there. I have to open up the applet.
Want to get it?
I can.
I'm kind of naked.
Hey, I'll be right back, Bernie.
Okay.
All right. They were trying to sell us weed control,
Okay.
like lawn weeds.
I'm having trouble getting that applet up. What did you get for that?
I got 0.184.
Okay. So.
And so the next one,
The p-value is greater than the level of significance, so we fail to reject.
Mhm.
Okay.
And then if we fail, or if we reject the null hypothesis, and the hypothesis is true, that's a type 2 error.
That's a type 1. Type 1 is committed when we reject a null hypothesis that is in reality true.
Oh, okay,
That'd be
yeah.
a type- Okay.
This whole rejecting and failing to rejecting always gets me.
Okay. A researcher decides that instead of using a level of significance of alpha equals 0.05, he'll use alpha equals 0.01, which of the following be true? That would be probability of a type 2 error will increase, right?
I think so. Because it would be 1% chance of a type 1 error. And if he used 0.05, the probability of committing a type 1 error would be 0.05.
Yes.
Tricky, tricky. Alrighty. Should we submit? And looks like we're good.
All right.
Well, sweet.
Okay, well, I'm going to